All right, I think we can get going. Looks like we're at critical mass. First of all, good morning and good afternoon, depending on where you're calling in from. My name is Daniel Holdridge. I would like to welcome you to the 3 Degrees virtual lunch and learn all about biochar. The webinar should last about 30 minutes, and we will have a dedicated time at the end for any Q&A. If you do have any questions during the session, please feel free to use the Q&A function within Zoom. And send your questions to all panelists. That way we can all see them. And we'll do our best to get to them at the end, depending on timing. With that said, let me introduce you to our presenters for the day. Wyatt and Serene from 3 Degrees Carbon Markets team. And taking a look at our agenda, we will do a quick intro to 3 Degrees and air miners. Delve into the main topic, biochar, showcase an actual project, and then finish with the Q&A that I mentioned. Now I'd like to pass it over to Jason to give a brief intro to Air Miners, our partner for today's event. Jason, take it away.
Great. Thank you, Daniel, and thank you to the 3 Degrees team for being such excellent hosts. And we look forward to future partnerships with 3 Degrees for advancing carbon removal. So air miners, what are we? Who are we? Since you might not know about our organization. Air miners, next slide, please, is a group that provides catalytic infrastructure to enable the first billion tons removed of CO2 removed from the atmosphere by the end of 2030. That's our mission. And the programs that we engage in follow from that, including onboarding people into the carbon removal industry from 0 to 1, how to educate. We have educated investors. We have an accelerator program for entrepreneurs. We also connect different players in the ecosystem, such as buyers, such as startups, such as other people who are engaged in the pursuit of removing greenhouse gas from the atmosphere to preserve our climate. Next slide, please. So our Launchpad is our accelerator program that we launched 3 years ago in conjunction with XPRIZE and Creative Destruction Lab to support the early stage of carbon removal startups. And to be clear, this is a worldwide accelerator. We're a worldwide community across all methods of carbon removal, including biochar, which is the subject of today's webinar. Supporting early stage startups in their infancy, we feel enables us to provide for a thriving carbon removal industry in years in the future. The landscape of carbon removal today is very much the landscape of startups, and we want to make these companies work and get them to a point where they can deliver on the promise of removing CO2 from the atmosphere. That's the purpose of our Launchpad program. Next slide, please. The Air Miners community is a larger community of over 2,500 people worldwide who are advancing the practice of greenhouse gas removal from the atmosphere, mostly CO2, a couple people in methane. It's self-sustaining, collaborating, and supporting other members along the way. Next slide, please. And finally, our Boot Up program. The goal of this program is to educate and inspire the development of people who are interested in carbon removal, who want to make a change into the industry, or want a broader sense of what the carbon removal industry is. This is a convenient starting point for those who are interested in beginning their learning journey in carbon removal, what it is. This is a 5-week program where people are involved with others in a group learning setting in small groups of 5 or 6 people for 2 hours a week. A link to do this is at bootup.airminers.com. And with that, I wanted to say thank you to Daniel and to the 3 Degrees team for providing Air Miners the opportunity to present to you today about what our organization is. And we look forward to speaking with you further. Any questions, feel free to contact me at jason@airminers.com. Thanks.
Thank you, Jason.
And Wyatt, please feel free to take it away.
Absolutely. Thanks, Jason, and thanks to Air Miners for joining us on today's event. Again, my name is Wyatt. I'm Product Development Manager at 3 Degrees. 3 Degrees is truly a global company, and we've been helping our partners meet their climate goals for many years across the world. I'm currently in our Portland office here in the United States, but we have a presence all over the world and work with project developers and counterparties really all over. So we're truly a global company supporting global climate change solutions. We're a purpose-driven company. You know, we've been around, we've been in the carbon market space for a really long time. We've done a lot of kind of early mover, initial step actors. You know, we really started heavy in the REC and carbon markets when they first started becoming active, as well as utility green power programs. We merged with other B Corp organizations to meet more and growing demand. So we kind of support this both on the business and the social level. And, you know, we're really excited about helping organizations achieve goals with their carbon emissions from various scopes, but also their, you know, renewable energy targets. And we think this is the best way to drive a more sustainable and equitable future for everyone. You know, we look at solutions to carbon, you know, in the typical scope way. You know, you talk about your scope 1 emissions, and we offer solutions for companies looking to do removals project or to do emissions projects within their scope 1. We also look to do that in scope 2 with things like renewable energy credits and power purchase agreements. And lastly, you know, we think about this in terms of the scope 3 with carbon emissions reductions, carbon removals like biochar, things up in the value chain, as well as transportation initiatives to decarbonize the transportation sector. The team that I'm on is a carbon markets project development team. We're about a 10-person team, and we're dedicated to developing new carbon projects and managing those carbon projects. So taking them through the verification, certification, issuance of carbon credits. You know, we vet these projects, and we look at these projects, we find certain projects for buyers, and we bring businesses who might not participate in the carbon markets, we bring them into the carbon markets. We help them, you know, make that leap into participating, and we're going to talk about one of those projects today. We currently have 25 active projects under like a long-term management with us, and we've launched 50 new products since 2004. We're very active in the credit generation space. We've, you know, issued, transferred, and helped retire a lot of carbon credits, and we're excited to keep doing that, especially in the scope of removals. With that, I'm going to kick it over to Serene, or no, I'm going to talk a little bit about the history of biochar, and then I'll kick it off to Serene to go into some of the technical details. Biochar is a really cool solution. It's been used for centuries as like an agricultural amendment, and for some other like water filtration and other technology types. We see it in different parts of the world. We see it in different forms. You know, biochar is, you know, a specific result of a technology process, but the chemical structure and the properties of carbon in this form have been used in a lot of different ways. You know, biochar was referred to things like ash manure, and there was the blackland and tetrapara that is mentioned in some historic literature in, you know, the Amazon and initial interactions into the Americas. I know that's technically that material was a little different from biochar, but the chemical purposes, you know, how it was used, its benefit on land and agriculture, were documented in a lot of those ways. Biochar has more recently made its way into the carbon markets. In 2008, the IPCC launched a special report, and it prompted that removal technologies were going to be a really big picture in meeting this 1.5 degrees Celsius target. Biochar is emerging as one of those leading candidates, primarily because of its scalability and its, you know, the co-benefits associated with it. And in 2019, biochar became widely acknowledged in voluntary carbon markets. Puro Earth launched the first methodology, and carbon removal credits from biochar started becoming available. Up to today now, we've got 3 approved methodologies. There is a climate action reserve methodology, a methodology with Vera, and a methodology with Puro Earth. And over, you know, we've seen 150 new plus projects being operational or currently in development for biochar projects. So there's really a lot of growth in this market, and carbon markets are playing a really big role in helping drive this technology's adoption. So it's a growing market. We're seeing a lot of growth in the market. 350,000 metric tons of biochar last year, which was a 91% growth rate compared to what we reported in 2019. The market is moving towards kind of a stabilization, but there's still a clear pathway to sequestration, and we really think that clear pathway is through carbon removals. There's a broader consensus that carbon removals are the best way to meet our our emissions goals in the long run, and many organizations are kind of standing behind carbon removals as the next step. And then, surprisingly, there's still a lot of space to grow in the carbon market. We talk about all this growth and we talk about all the great things happening, but I think it's important to look forward at the opportunity that's still there. Over 50% of global production do not report any income from carbon credits. And so there's still big untapped market potential in this carbon space. And we think, carbon removals, and in this particular instance, biochar, is going to be a really cool way to do that. And without further ado, I am going to kick it over to Serene to talk a little bit about the technological process for how we make biochar.
Hi, everyone. Thanks, Wyatt. My name is Serene. I am on the operations team within the carbon markets team here at 3 Degrees, and we are the ones to handle all the monitoring, reporting, and verification for these projects and really push them through the registries to ultimately generate credits. So I'll be talking here a bit about, the basics of biochar, what is it and how is it created? So you can kind of see the graphics that we have on screen. First, you kind of have your input, which is biomass feedstock. That can be things like wood waste, crop residues, biosolids, et cetera. And typically this biomass, if left alone, would have been left to decompose and release carbon into the atmosphere. And so to prevent this from happening, that feedstock goes through a process called pyrolysis, which is essentially just, high heating the biomass at a really high temperature and in the absence of oxygen. And as a result, you get biochar, that output there, which is a highly stable form of carbon. And biochar is really unique in that it has a really high permanence or stability, meaning that it has a low risk of breaking down and releasing that carbon back into the atmosphere as per the typical carbon cycle. And this stability or permanence is something that you'll hear a lot, about this project type. It's really a defining factor of biochar. Next slide, please. So there are a bunch of different types of feedstock biomass that can be used to create biochar, and that typically depends on the methodology. Some methodologies allow for purpose-grown feedstock, which means that feedstock can be grown for the purpose of creating biochar, and other methodologies only allow for waste biomass to be used. But something I want to highlight here is that part of 3 Degrees is due diligence when we're looking at feedstocks of certain projects. We're going to be prioritizing projects with feedstocks that have high likelihoods of being left to decompose, like waste biomass. And this can be things like residuals from forest management or agricultural waste, or just sort of other type of waste biomass. That's something we're looking for. Next slide, please. Right. So yeah, as mentioned in my previous slides, biochar is, unique in that it's a stable carbon product of biomass that would have otherwise been left to decompose. And right now, as Wyatt mentioned, there are 3 methodologies that projects can use to calculate the amount of carbon stored in the biochar produced: Puro, Vera, and CAR. CAR's protocol is still under development. It's waiting board approval, I believe, as of March of this year, so still undergoing that development process. And Puro and Vera are both undergoing their first revision, so their methodologies have been out and generating credits for a while now. They're just iterating on new versions. But that's all I have. Passing it back to Wyatt.
Thanks, Serene. I think now's a good time to kind of jump over to one of my favorite analogies about carbon removals and carbon reductions. This is a good way kind of to think about it and why it's so important in facing our climate challenges. So if you think about a bathtub or any body of water, you have your emissions flowing in, and it's filling up that tub. And we're increasing the amount of the natural cycle and the natural things that take CO2 out of that process are being overwhelmed by the flood faucet that's turned on and pouring in from human-based activity. And so we have two ways that we can kind of combat this. We can slow down the flow rate on the faucet. We can do reductions. We can emit less. We can kind of turn down the amount that we're pouring into the tub. Problem is right, we're still pouring into this tub, and the tub is still being filled up. And until the natural cycle until we're emitting equal to what a natural cycle would be able to handle on the Earth, then we're still going to be seeing emissions increase, and we're still going to be seeing climate change problems associated with those. And so the other solution is a removal, which it's the process of actually taking carbon dioxide out of the atmosphere or out of the natural cycle and putting it in a state where it stores for an extended period of time. And so biochar is an example of that. As Serene talked about, you have the human-based activity in the normal carbon cycle. You have materials that are from human activity, forest fire, other things like that, that left to their own will either decay or we'll burn them, and they'll be combusted into CO2. And if they decay, they'll decay into CO2 and methane. But another option is that we can take that carbon out of the carbon dioxide natural cycle that would otherwise be increased by our activities, and we can store it in a way where it's going to stay there for a long time and not contribute to short-term climate change issues. Certain types of removals store longer than others. Biochar, depending on how it's used in its final form, can be stored in carbon for 100 to thousands of years, depending on what's actually done with the biochar once it's made. This is kind of a good tangent to talking about net zero goals and how big of a role carbon removals play, particularly for their low risk of reversal. So reversal is this idea that a carbon activity, some other event or change in activity will undo the benefits created by the carbon emissions reductions. And so as you can imagine, certain project types that are more where the carbon is in a form where it could be more easily re-released, think if you have plants and you're storing carbon in a natural cycle and something happens to those plants, you cut those trees down, that field gets burned, there's a flood, different kinds of events can reverse those benefits that you were crediting in emissions reductions. And so part of this big transition process to a net zero target really removes on lowering what we emit, focusing on our scope 1 emissions, focusing on our direct emissions and bringing those down. And then when it comes to how we match emissions that we can't get rid of, there's a high shift towards this value of carbon removals as being a long-term, sustainable, and durable solution to drive positive climate impact. And you can see as the Oxford principles kind of align with this net zero target for carbon offsettings. You can see the role of removals in terms of the actual actions taken in the carbon markets to address these. Through 2030 up to 2050, start taking over the majority and ultimately become, most or all of the carbon market activity in the form of these removals. There's some other project types, different categories. We typically think about them in three kind of buckets for carbon removals and how we categorize them. There's the biological solutions. So these are storage solutions they're still good permanent storage solutions, but a lot of times there's a little bit higher reversal risk on a project like this. That's a universal risk that we do everything we can to mitigate, and the markets has mechanisms for making sure that those are still creditable and part of our package solution to dealing with emissions. Then we have the hybrid categories, which biochar is included in, primarily because most of the time, or almost all the time, the feedstock for biochar is a biomass. It's a biological substance that's being turned into biochar. Another form of hybrid solutions is bioenergy and carbon storage. So you might have heard a term BECCS, or taking carbon out of fermentation processes and other things like that and storing it in the ground. And then there's the truly engineered solutions. Concrete, uses CO2. It's a place we can store CO2, so you can take concrete, You can take CO2 and you can put it into the concrete during the mixing process, and it's stored now in that concrete. So however much CO2 you put into the concrete process, and depending on where you get that CO2, there could be a negative, there could be a removals impact on where you're sourcing that CO2 and then storing it in storing it in concrete, preventing it from going in the atmosphere. And then of course, we all hear lots about direct air capture, the actual act of just taking carbon right out of the air and doing something with it. So a very mechanized way to remove carbon from the atmosphere. These all represent different tools that are in the toolkit. Today we're really here to talk about biochar and some of its co-benefits. So we've got a couple co-benefits from biochar. These are kind of the four, big ones that stand out. Really, it's got we really think about most of the co-benefits of biochar being associated with its use in soils. Biochar it's a soil amendment. It can be used to increase soil fertility, promote healthier storage, increases the capacity to hold water, which is especially important in communities affected by drought, especially increased drought in the face of climate change. Biochar offers some unique co-benefits to that. A couple other end uses for biochar outside of soil. Biochar can be used for it can be added as a material in concrete as a replacement to something like Portland cement, which is really emissions intensive to make. Biochar can be used there. Biochar can also be used for environmental remediation, so things like plugging abandoned mines. So it has a good porous property of leaching up certain things that you don't want to get into the water supply. Biochar can be used as a kind of absorber or filtration for things like that, which are some of the other co-benefits. We typically think about it in soil. Most of the early carbon market view of biochar was imagining a soil end use, although there's emissions benefits with a lot of those other end uses as well. More broadly, we talk about these sustainability development goals of carbon sequestration. This checks a lot of the boxes. A lot of the boxes as promoted by the UN Sustainable Development Goals. You can kind of see here, you've got soil health, you've got economic benefits to farmers. I think that's one of the things I really like about a lot of these projects is that the projects that we're really involved in, the recipients are farmers, they're small lumber businesses, they're different actors in the space who are getting access to these benefits, which is really important. Remediation, I called that out in one of the air ends. Of course, air pollutions, that's the big one. It's a carbon removal. Biochar, also the production, while biochar is also produced, as Serene mentioned, when she introduced kind of the technology of biochar, there's usually a pyrolysis gas and an energy stream that's also created. And so it can be a source for clean energy, either as a heat source or as an electricity source. And I think one of the main drivers is it's also a solution to waste management. Those who've worked in the waste management space know, we put a lot of time and energy into managing waste streams. It takes a lot to deal with our waste. We have landfills, we have different processes for composting, and biochar offers a solution for that not only offers the methane emissions from dealing with it in a more sustainable way, but actually the carbon removals benefit, which is really cool. So now we're going to highlight one of the projects, one of our recent projects with biochar. It's a company called Southwest Biochar. What's been really exciting about this opportunity for me and working with Tyson and his team there is the story of this biochar facility is a lumber company, Arizona Logs, working with the Forest Service in Arizona. So taking tree thinnings from sustainable forest management, and also catastrophic wildfire prevention. We know wildfires are good for forests, but catastrophic wildfires are bad for forests and for communities. And so one of the ways that can be managed healthy is through sustainable forest management practices. So trees that are thinned in Arizona for the purpose of avoiding catastrophic wildfires and promoting healthy forest growth. That material is then used in industry, used in lumber, and there's a lot of waste from that process. The process of turning felled trees, especially the smaller parts of the trees, think the branches, the bark, the cuts that don't perfectly make it into the 2x4. That material otherwise usually would be burned. A lot of times we do see that it gets burned for energy, but it's still burned. And at the end of the day, that's a lot of carbon that we're releasing back into the atmosphere. And so it was really cool to hear the story, a family-owned business, father and son, son getting involved with the Southwest Biochar company and, making kind of the next transition for this business that had been around for a long time, and allowing kind of the next generation of the business owner to participate in carbon markets and be really active and actually in an advanced technology type. So that's something that I've been really happy to work on this project. It's been really cool and a really fun and personal experience in carbon markets, and a really cool outlet into biochar. Serene's going to talk a little bit now about the actual development processes and kind of where the project is and where it's going.
Thanks, Wyatt. Yeah, so this project is definitely still kind of, getting off the ground. It's in its pilot program, as Wyatt mentioned. The feedstocks are, wood waste from lumber operations and forest thinnings through the state's forestry program. And that feedstock is, a result of fire suppression activities. So you have, again, that added kind of co-benefit there, and the application or end use is actually intended to be, local agricultural operations. Staying local or nearby for the biochar end use is always great because it, decreases the overall life cycle emissions of biochar production. And so, yeah, that's just kind of the summary of, this project specifically, and their feedstock, their application, where they come from, how they got into this space. And yeah, we're really excited to kind of support this project as it starts to generate credits. That's it for me.
Well, that brings us to the end of our scheduled content. We have time left over here to answer questions and to kind of jump in the Q&A. Happy to stick around and talk about biochar, answer, what questions we can. And
yeah, thank you, Wyatt. Thank you, Serene. We do have some questions popping up in the chat. Here's one. What is a tolerable amount of moisture for pyrolysis?
Yeah, I can jump in there. It varies by the technology, the pyrolysis machine. I think that's been one really interesting thing to watch evolve. Typically, as kind of mentioned in the Q&A there, that kind of like low, really dry 10-20% kind of moisture content is important, because if you think about it, if you have a really moist material and you're converting it into biochar, the water that's in that material is not going to convert into biochar. It's going to be converted into steam. And so there's a lot of energy that would go into, converting that water into steam. And if that makes up a really big component of the mass, that definitely affects the efficiency. So a lot of times that's part of the process of chipping and drying material before it goes into a biochar pyrolysis machine. However, I have seen pyrolysis companies, advertising taking things as high as 40% moisture content, because they have kind of custom engineered their solution to take those more fresh materials that haven't been processed. And so it's really exciting to kind of watch that evolving too, as more attention is drawn to biochar and more businesses and waste streams find the use for it. The engineering teams that are working to create this kind of equipment have been responding and adapting to that.
Here's another one. Can biochar only be made from organic matter, or can recyclable plastics be converted to biochar as well?
Yeah, that's a good question. I've seen examples where organic, like plastics, recyclable plastics, and some of the carbons in those are being taken out into biochar. For carbon markets purposes, it's mostly been framed around biomass initial sources. The quantifications of that are pretty straightforward. The other kind of challenge with that it's still good. Like, we don't want plastics in landfills and polluting that, but when we're thinking about short-term climate change, plastics, one of the things we know about plastics is that they take a while to decompose, right? That's the thing we're always taught. Like, when we put plastic in a landfill, it's there for a really long time. And so the emissions associated with things like plastics and other really durable forms of carbon that we produce are harder to credit and account for, because those sources aren't likely going to emit for a long time.
Here's one about the cost. What is the range of cost per ton of carbon in the production of biochar?
Yeah, that's a really good question. I mean, the range is pretty broad. I don't have a good exact number off the top of my head for that, but some of the big factors, what is, the location, the transporting of the material often plays a really big part in the cost. These machines aren't cheap, depending on the size. A machine that makes a couple tons of biochar a day, can be hundreds of thousands to $1 million. A bigger setup that's making 40 tons of biochar a day can be in the couple millions to develop. But there's revenue streams associated both from the carbon revenues biochar and also the sale of the biochar material itself and the bioenergy. So the costs of production can vary a lot. It really, and the processing is another big part of that. If you have a really, if it's a material you have to pull out impurities from, pull out non-organic material from before you chip it and do stuff, can really drive up. So we've seen wood waste projects have pretty good low cost to entry for stuff like this, and agricultural projects, because the waste stream is more easily accessible, and oftentimes can be dried pretty easily and converted into biochar.
Great, thank you. Is there a preferred standard for biochar carbon certification in terms of market acceptance?
Yeah, I can take this one. Yeah, the methodologies that are currently out refer to two standards, two certifications that are preferred. The first is IBI, which is the International Biochar Initiative, and the second is EBC, which is European Biochar Certification or Certificate, one of those words. And yeah, they're both slightly different. EBC has some more kind of categories of certification. You can certify your biochar to be like, just a basic material, like a feedstock for food. There's like many categories for that. IBI is a little bit more general. And so depending on the char you're producing, you could go for either of those certifications, but typically both of them are kind of, the standard that we like to go by.
Thanks, Serene. Is the drying process used typically passive, or does it require an energy input?
Yeah, a lot of times it requires energy input. It's part of the life cycle emissions associated with operating the biochar project. That's not the case all the time. There are instances where the biochar is on material that's been left to dry for a really long time. But yeah, often chipping and drying is one of the energy inputs. The thing to note here is that as these systems evolve and get designed, is one of the co-products of producing biochar is producing energy. And so there's good opportunity to use some of that energy, not only to drive the pyrolysis process, but to drive some of the other processes like the chipping and drying. Obviously it's never, no system is self-sustaining. There's always going to be some form of energy input required externally to keep a process going. And so, but we can minimize that, and we can be really efficient about that by using the energy from the pyrolysis.
Great. Here's one kind of around the use of the biochar. What kind of crops can the application be used for? And can you provide any specific examples?
Yeah, I could point you to a specific resource. I know Washington State University has published a good amount of literature on this, as well as I believe Texas A&M both have programs that have done a lot of research for biochar, specifically on the Washington State University research program has done a lot of research on how different crops respond to different flavors of biochar. I guess, there's different things you can do and tweak in the process to make it more effective for agricultural end use. The initial feedstock also plays into a role for that. And so maximizing the benefits associated with the biochar has been a really interesting advent of the technology as it's gained more popularity. There's more focus on different types of biochar and how to make biochar that's better for specific crops, that's better for, some feedstocks make a really good absorbent biochar that's really good for that mine remediation thing, and some feedstocks make a really good one for agriculture. I had the opportunity to tour a facility that was kind of looking at different feedstocks and how they affected plants, and they were testing things like the perfect ratios to apply, and tomatoes benefit from feedstock that's from tomato waste projects was something that they had kind of showed. And there's developing research in that space on how we can maximize those co-benefits.
Yeah, and EBC that I just mentioned, the European Biochar Certificate, in those different categories of certification, they also kind of list out the not only the feedstocks that would be used, but also the pyrolysis conditions. And so, yeah, as Wyatt said, there's many different flavors of biochar that can be produced, and that depends not only on feedstock, but also pyrolysis conditions. And so with that, many combinations can be made.
Great, thank you both. What is the generally accepted permanence factor for biochar? We mentioned 100 years, but is there a general acceptance?
Yeah, in the current landscape of emissions, calculations of, the carbon, in the calculations of how much carbon is being stored in the biochar, it is assumed to be 100 years. Although, there are, new research coming out all the time and kind of developing thoughts on, the permanence being actually higher than that. That's a kind of a subject of interest, I think, for this industry moving forward. But yeah, for right now, the assumption is 100 years.
A question on Southwest Biochar. Why did the project choose Puro for the certification?
That's a good question. I think, well, I guess why you talk to them more on this. I have my guesses, but maybe you can answer this one.
Yeah, I think one of the reasons that Puro was selected, there are kind of two big reasons. One was just kind of the frequency and timeline of how the issuance schedule works on Puro was appealing to the business model and to the operators. The other was that a lot of the people involved on the counterparty side, like the developer, the technology, and the project itself, are interested in one of the things that Puro offers is the index pricing for biochar. So they're providing kind of a tracked price for the exchanges when biochar removals are sold. And so some of that price transparency and contributing to the broader market understanding of carbon pricing and carbon removals was something that was important to some of the people involved in this project. And so those were the two main factors that drove towards Puro.
Here's one kind of for your project development side. Can you explain the differences of some of the equipment that's being used and kind of how you would recommend one piece over another for a project site?
Yeah, I would definitely direct you to some of the resources available on the USBI, US Biochar Initiative. They've got some good catalogs and researches of different machines for different technology types. The biggest kind of difference in the machines and variation is the scale and what the primary or what the ratios of production are. So smaller machines often only produce like a little bit of energy, but they're kind of mainly focused on turning most of the material into biochar, sometimes at scale and efficiency. If you're taking large volumes of this material, the ratio of what's being turned into biochar and bioenergy, you might have more bioenergy. There might be reasons and benefits to do it that way. So I think, just starting with the scale of how much biochar you're looking to produce can kind of put you in a bracket of, what tech developers are building equipment that is in that space of input output. So some of the tech developers really focus on really big biochar machines, others focus on smaller, more deployable biochar machines. And selecting it can also be a feedstock consideration. A good question to ask if you're talking to biochar manufacturers is, look at your feedstock and say, have you had experience with your machines turning this kind of feedstock into biochar? And some might say, yeah, like we're really confident that we have a good machine for this particular feedstock. And I think those are the good kind of questions to be asking if you're looking to get biochar equipment.
Great. As a soil amendment, what is the N2O nitrous oxide emissions impacts when applying to land?
That's a great question. There are likely those emissions, but in kind of the total life cycle analysis that we're doing for these projects, it sort of ends right at soil application, because there's the assumption, there's an assumption for all these projects that once it is applied to the soil, then that's kind of an ideal kind of end use for maintaining that permanence, that stability of biochar. And, in the entire kind of project boundary of sourcing the feedstock, creating the biochar, and then application, that's kind of where we draw the boundary for those projects. I'm not sure if I answered that question, but.
Great. Thank you, Serene. Here may be a tricky one for y'all. Let's see if y'all have these numbers right in front of you. Do you know how much of the megatons that we mentioned before produced in 2023 were from the United States?
I don't know the exact number, but I can definitely ballpark, picture this. Most of in carbon markets in general, actually, there's a really good graph that I wish I had somewhere that shows where the majority of carbon credits come from and where they're retired. So most of biochar products that have been generated in 2023 came out of Southeast Asia and Africa, and with heavy influence on Southeast Asia being the source of a lot of those projects. I know of a lot of large biochar projects, lower tech biochar projects. So using like smaller kind of distributed systems in India. That's definitely changing though. If you look at where biochar projects are being developed, especially when we talk about high-tech biochar with like pyrolysis machines and, kind of industrial repurposing of waste streams, we're seeing a lot more projects coming from Europe, North America, South America. Yeah.
Cool. I think we might have time for one more. Here's kind of one on the generation of credits. If we spent biochar on soil amendment as part of land restoration project, could we claim carbon credits for each ton of biochar we apply?
Yeah, so soil amendment and soil end use, again, is within the project boundaries. And so you can't claim sort of additional credits for, applying your biochar to soil, if that is the question. It's sort of assumed that there needs to be a suitable end use where, carbon storage is long-term and stable. And one of those end uses is typically soil amendment or soil end use.
Thanks, Serene. And with that, I'd like to thank everyone for joining us. Jason, Air Miners, Wyatt, Serene for presenting. Everyone have a great afternoon. Thank you so much.